Hey everybody, it's Mr. Carr again. Today we're going to be looking at 9.2 day one. We're looking at parabolas. Now it seems like, hey, we already did parabolas way back when. And that's true. But we're going to look at them in a slightly different way. It's called a geometric approach here. Okay, so let's look at a slightly different definition of parabolas. A parabola can be defined as the set of all points in a plane that are the same distance from a given point called the focus. Okay, so our focus is one of our first new terms that we're going to cover today. And it's also the same distance to a given line called the directrix. Okay, so you see this image right here. So here's my parabola. Here's the focus right here in that spot. The directrix is right here. Now, when you look at the vertex, for example, the vertex is the same distance here and here. Like that distance right there is like whatever it is, like the focus is right in the middle of those 2 points. So it's like a midpoint of those. If I pick any point on the graph, so if I pick like this point right here, the idea is that this distance is the same to that distance. So no matter where I go on the parabola, and I find that if I were to find the straight distance there and the straight distance there, those two lengths are the same. So those are the same, and those are the same. Use some more geometry stuff there. Okay. There's a line segment that exists that goes right through the focus and has the endpoints on the parabola, and that's called the latus rectum. Okay. Sorry about that. Okay. So the latus rectum. So it's perpendicular to the axis of symmetry. So it's just its own little line segment here. So one of the things to mention is that the y values of these two endpoints is the same of the focus. Now, here's the thing with this definition, we don't have to do this parabola that always opens up or opens down. We can actually have them open left and right. And here's how that changes. So this one is more of a traditional one. We've seen stuff like this on the left side here. Okay. We've got the x minus h squared plus k. We did that. That was part of a previous thing. If I swap it around and make it x is equal to this idea, so like a basic version of this would be x equals y squared. X equals y squared. That's going to get a sideways going left or right for the opening. Okay. Now, this is a new thing here, this 1 over 4p. That is going to help us with our focus. That p value is going to help us understand where the focus is. So wherever the vertex is at h and k, if it's opening up or down, we basically take the y value and add the value of p to it. Okay, which means if it's negative, then you're going to subtract it. You're going to go the other direction. So again, if p is positive, it opens up. If p is negative, it opens down. When we have it in this setup on the sideways one right here with the 1 over 4p, now if this is my vertex here, the focus is going to add to the right or to the left. So what we do is we take that p value, we add it to the h, to our vertex, the x value of our vertex. Okay. Axis symmetry. So this case is x equals h just like before, but now in this case, if it opens sideways, it's y equals k. That's going to be our axis symmetry. The other part is our directrix. The thing about remember about the directrix is this is the same distance between like the directrix and the focus. The halfway point between those is the vertex. So whatever p is here to get to like the focus point, we actually do the opposite of that to get the other way. So that's why in this case, if we take the h value plus p, the directrix is going to be the h value minus p. Okay. So now remember also with the directrix, this is in this case, when it's sideways like that, the directrix is a vertical line. All right. Let's get back there. It's a vertical line here for the directrix. Here it's a horizontal line. All right. And it's not on here, but don't forget about the idea of the latus rectum. If I draw a point this here and this here in this case, the y values are going to match up to the focus point. If I draw my latus rectum here, now it's my x values. Okay. So all three x values are the same between the focus and the two latus rectum points. All right. So I've got two examples to go over. Let's look at negative 1/4 x squared. So we want to graph that. To help me graph that, though, before I get into this, I want to find vertex, focus, latus rectum points, and the directrix. Okay, so we're going to go through that process first. I'm going to go through all algebraically. First thing is, again, with the h and k idea, my vertex is very easy. It's 0, 0 in this case. We don't have a number inside the parentheses with the x, and we don't have a number afterwards. Okay, so the vertex is at 0, 0. The focus The focus, we have to do this part first. We do 1 over 4p is equal to a negative 1 over 4. So if I look at that, I can recognize that 4p and 4, well, negative 4, I should say, match up. So 4p has to equal negative 4. So if I divide both sides by 4, I get p equals negative 1. So that means my focus, remember this one, and I forgot to mention this, because it's x squared, it's either, and it's a negative x squared, we know it's going to open down. Okay, so I know it's going to be right here for my 0, 0 for my vertex, plot that point. My p equals negative 1, so I'm going to go negative 1 in the y direction. So I'm going to have the same x value, 0, and then negative 1. Okay, so here's my focus point is right there. Then let's find the lattice rectum. So lattice rectum has the same y values as the focus point. So it's negative 1. So algebraically, I'm going to say, hey, when does the negative 1 over 4x squared equal negative 1? Okay, so if I multiply both sides by negative 4, cancel that out, I get x squared is equal to a positive 4, and then I square root so I can get a plus or minus 2. That's my two endpoints. Okay, it's a positive and negative 2. And again, it's got to have the same y value. So for my lattice rectum points, I got two of them. I got a negative 2, comma negative 1, and I got a positive 2, comma negative 1. So negative 2 right there, positive 2, and there. Okay, I've got enough to graph it. I'm going to go ahead and just graph that parabola right there. It's looking like that. The last thing is the directrix. So remember the directrix, if this point, come on, here we go. That's 1 point away from between the focus and the vertex. The directrix is going to be one more point this way. So it's going to be this horizontal line. Okay, so just if I look again from the vertex, I'm going to, instead of, I took -1 to get down to the focus, my directrix is going to be the equation y equals 1. Okay, and that's my process. And again, I was able to do all that without a graphing calculator, all algebraically using our definitions. For the second example, we're going to do something similar with this one, but now look at that. It's a y squared. Okay, and it's a positive 1 over 16. So I know it's going to do something like this. It's going to open to the right. First things first, we do the vertex, 0, 0 again. There's nothing inside the parentheses, nothing afterwards. For the focus, I'm going to do 1 over 4p is equal to 1 over 16, which means the only way for that to be true is if 4p equals 16, divide by 4, and I get 4. This is going to go, so here's my 0, 0. It's opening to the right, so I know it's got to go 1, 2, 3, 4 to the right. So y, so for my focus, is the point 4, 0. Okay, lattice rectum points. Again, it's got to share the same x values in this case because it's going to be a vertical line segment that goes right here. So if that's the case, then I need to do this. I'm going to say 4 equals 1 over 16 y squared. Multiply both sides by 16. So 64 equals y squared. And then I square root to get plus or minus 8 for y. So my 2 points are at 4, positive 8 and 4, negative 8. So I can go, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. There we go. All right. And the last thing is my directrix. To get that, again, the distance here is 4. So it's going to be 1, 2, 3, 4 this way. So I can draw that as a vertical line there. Like this. Okay, so in this case, it's a vertical line, so it's going to be x equals a negative 4. And again, it's the opposite direction of the focus, but it's the same distance between the focus and the vertex. Okay, and that is it for our graphing of our parabolas. We're looking at it a slightly different way than we've done in the past. Now we're focusing on focus, vertex, and the lattice rectum points to help us graph, also recognizing where the directrix is. Okay, that's it for today. Take care, everybody.